And thank you for joining today's webinar. I'm Lucy Hoda, Senior Vice President of Media and Communications for Competitive Carriers Association, and I will be your moderator. Today's webinar is quite a popular topic in the wireless industry, and I'm really glad to be here with our presenter, Hooman Razani from Award Solutions, who is going to tell us everything we need to know about deploying VoLTE. I would also like to thank RCR Wireless for hosting the webinar. Before we begin, I thought I would speak just a moment about CCA for those of you who might not be familiar. We are an advocacy organization based in Washington, D.C., and we are made up of nearly 100 wireless carriers and approximately 150 associate members, which are the vendors and supplier companies that do business with the carriers. CCA's priority is advocacy, and some of our members' top issues include access to spectrum, USF and the more recently announced 5G fund, communications network security, and many other issues. This slide shows some of our significant accomplishments over the years, but as the last slide indicated, we're not only about advocacy. Part of CCA's mission also includes providing networking and educational opportunities to our members, including things like this webinar, and our annual trade shows. CCA's 2020 Mobile Carrier Show is coming up at the end of March, and I strongly encourage you to check it out. We've got a great lineup of speakers, including US Cellular's President and CEO, Ken Myers, who's going to be one of our keynotes. There are a ton of networking opportunities, and there really is no better place to meet with executives and key decision makers from these carrier companies. Early bird rates end next week on February 21st, so register early to get the discount. Award Solutions will also be at the show hosting a special training session on 5G and VoLTE. Award Solutions is a longtime member of CCA, and we partnered with them last year to bring a series of training sessions to CCA members, which have been greatly successful. And Hooman can tell you a little bit more about that as well. For the webinar this afternoon, if you have any questions throughout, please ask questions using the chat function, and we'll try to answer them as they come in. And then otherwise, we'll leave a few minutes at the end to answer questions as well. So Hooman, I will now turn it over to you for the presentation.
Thank you very much, Lucy. This is Hooman Razani, Senior Consultant at Award Solutions. I would also like to say a couple of words about Award Solutions, who's a training partner to over 255 cable and wireless companies worldwide. We're based in Dallas, Texas, where the company was founded more than 20 years ago. Award Solutions delivers training at the onset when the technologies are first deployed with the chipset vendors and then all the way across the technology value chain. The majority of the training we deliver, though, is with North American carriers as they evolve their networks and look to enhance their organization's skill set. We are very pleased to partner with CCA to offer 2 certificate programs. You can see them here, one on foundations of VoLTE and the other on foundations in 5G. You can actually use your cell phone's cameras to hover and capture these QR codes in order to learn more details about these courses. I will be very happy to also answer any questions you might have about Award at the end of this session. Great, thank you again, and let us now look at our topic today. So we're going to be talking about deploying VoLTE and what we need to do that properly. So I will start by giving some objectives here. First, we want to understand how will VoLTE impact the network? What are the main impacts of VoLTE as we deploy the technology for supporting voice services on LTE? Then we look at some key challenges with deploying VoLTE, and these challenges are many, including interworking and roaming, which are not easy to make happen properly and without any problems. We also want to inform you about the proper way to go about looking at the challenges and options involved in deploying VoLTE. There is a myriad of options in deploying VoLTE, and it is not easy to wrap your head around in terms of what needs to be in place in order to give the best user experience to our customers. I do want to say that as I go through the slides in this chart, we will not be going sequentially through these objectives, but through almost every turn and discussion that we have out there, we will be talking about these challenges and key deployment issues with VoLTE. Let us now look at, I actually do have already a question on the chat, which is great. about the impact of VoLTE on 5G technology, or what is the relationship between VoLTE and 5G technology, I will actually address that as we go along on a couple of slides that are about to come. So why VoLTE? Well, we talk about over-the-top applications. It is well known that the Googles and the Facebooks and Apples of the world have a very good grasp of the content out there that runs on our networks. Now, voice has not been immune to this either. There are tons of good apps out there that provide instant messaging and voice services out there, like Skype, WhatsApp, and so on. But the fact is that these over-the-top applications, OTT or over-the-top applications, do not provide all the bells and whistles that one might imagine one would need in the traditional sense that the circuit switch world has been providing voice services. I think one very good way to think about VoLTE is to think of it as an application that we own. The operator owns and caters for the operation of this application end-to-end between the device all the way to the IP multimedia subsystem that we're going to be deploying for providing this service. Now, the main motivation for VoLTE, I think above all, is the fact that these over-the-top applications, which by the way sound fantastic in terms of quality and user experience most of the time, and can be used even internationally, they do not support things like the ability to call the PSTN. After all, a large portion of the calls are not between VoLTE users, but between the VoLTE user and the public switch telephony network. How are we going to deal with that? If you have an over-the-top application, the only way you could do that is actually to pay a little money to some of these applications in order to have a phone number and be able to make that call. So in my opinion, VoLTE is highly motivated for these two main reasons: regulatory reasons, the ability to call E911 services, as well as PSTN interworking and operations. Yes, it is true that we can also cater for policy and charging control. We can add video on top of this, or visual voicemail as in rich communication services, or support the well-known supplementary services such as call waiting and caller ID and things like that. Reliability and quality of service are also things that we can now be in charge of, since we are doing VoLTE as our own app. But the fact remains that, in my opinion, PSTN and PSTN interworking and E911 stand out as two very main reasons for why we should be doing VoLTE. Finally, back to the question that was asked, it is absolutely true that any 5G deployment today is going to rely on VoLTE as the carrier of the voice services. All major carriers in North America who are deploying early 5G deployments in what is called non-standalone deployment are going to rely on the 4G leg as the provider of the voice services in conjunction with 5G. Very good. So, in my 20+ years of consulting for wireless carriers, I have quite often come across situations where the best solution for a problem is not the most sophisticated or expensive one. And this is also true for the problem of voice in LTE. So it is actually not a bad idea to put VoLTE in the context of the voice solutions in LTE in general. And it is well known that some 7-8 years ago, when VoLTE was launched for the first time, a major US carrier provided voice services by actually allowing the handset to be dual radio capable. The handset can be on VoLTE, the handset can be on LTE and a 2G, 3G network simultaneously, so that the customer would have the experience of simultaneously being able to make and receive calls on the 2G, 3G network, and at the same time enjoy browsing the internet or have access to data services on the 4G side. Now, 7 years ago, people would raise an eyebrow or two and say, wait a minute, these handsets are going to be very expensive. Dual radio, after all, is almost equivalent of taking two handsets a 2G handset and a 4G handset and gluing them together. Now that would be impacting on the handset. But this is a great solution. It has low impact on the network. Most of the burden is carried by the handset, and it provides a voice solution for us in the network. Now, what I said about 5G, the fact that 5G is supporting LTE and so it's supporting voice and data at the same time, implies that 5G handsets are also dual radio devices. In other words, this business of having a handset that does two radios is not such a big deal today. And one might question actually and ask whether this type of solution would actually make a comeback or be actually a possible solution for providing voice in an LTE environment. The problem is, after all, availability of handsets that can do 2G, 3G, and 4G simultaneously. They're not easy to come by. The next solution is to actually, at the moment of call setup, let the call to go to 2G or 3G for where the circuit switch services are available. This is an interim solution that was also deployed in North America by many carriers, and it has many advantages too, because the impact on the network is small, but the result is very good in terms of user experience, because you will always be able to make or get that call when you are on LTE network. Now, finally, we have the VoLTE itself, which is the main solution to our voice problem in LTE. It requires an IP multimedia subsystem, or IMS, as you can see, and this is what will give us all the bells and whistles that we would need for providing a very good and high impact voice service in the network. But that is not all the story. We know that people who deployed VoLTE initially had to struggle a lot with the coverage issue of their 4G network. What if I do not have a top-notch coverage in all areas of my network, and there are still pockets of areas where my 2G, 3G network has better coverage? It is because of that the entire VoLTE solution can be augmented or enhanced by another technology called single radio voice call continuity. If I, as an operator, imagine that I do not have the coverage to confidently provide VoLTE services, I should seriously consider the introduction or the use of the single radio voice call continuity for allowing my customers to be making VoLTE calls in my LTE network, and mid-call, hand over or transfer the call to the 2G or 3G network, which might have better coverage at that spot than my LTE does. So we are not going to be talking too much more about SRVCC in this presentation, but it's a very important consideration that one must have in the back of the mind when we decide to go with VoLTE. So let us look at, in general, the VoLTE scenarios that should be available to us when we deploy VoLTE. First, we need this IMS cloud, IP multimedia subsystem. It's a sophisticated cloud with multitude of functionalities that allow a variety of scenarios to be used for making and receiving calls. For example, we would all like to make VoLTE to VoLTE calls, voice or voice over video, and enhance it with video. In other words, may be able to make a video call. IMS is going to be the call control cloud for providing VoLTE to VoLTE calls and VoLTE and video calls simultaneously. Without IMS, VoLTE is not possible, and therefore IMS is really the main enabler for VoLTE. Now, let us not forget that IMS was invented long before LTE. And in fact, it is only with the advent of VoLTE and LTE that it found its main application and has become the predominant method to provide voice services in LTE. The other scenarios that we absolutely need to take care of and be able to do are, of course, VoLTE to PSTN calls, the interworking that, as I said, the over-the-top applications cannot provide unless we pay a little bit. The other thing is, of course, VoLTE to other operators. In other words, VoLTE calls between operators is another scenario that we absolutely need to consider, if not put in the put back in our project plans and try to do this a little bit later. I very well remember that back in 2014 or 13, when the first VoLTE services started to show up, AT&T and Verizon announced that they will soon be providing the ability to make inter-operator VoLTE calls. It took many, many years before the problems were all sorted out and an inter-carrier VoLTE call was possible. Even today, it is not entirely void of problems as we make inter-operator VoLTE calls. Finally, last but not least, the PSAP and the operators and E911 services are essential for VoLTE for regulatory reasons. And because of this, the IMS infrastructure might even have dedicated nodes for providing emerging services and the like for making E911 calls possible. E911 is a very sophisticated technology where it is not just about getting to the public safety access point, but also the ability to retrieve position information about the device so that the aid can be dispatched to the distressed caller at any given moment in time. So a more sophisticated look at VoLTE, therefore, might be voice over IP with a quality of service that we as operators can cater for and design or shape using LTE and IMS. So what do I need to have to do VoLTE? Above all, and starting point is, of course, a device that has the VoLTE application. Just like a device that needs the over-the-top application like FaceTime or WhatsApp to be making the over-the-top calls, we have to have a VoLTE application in the device. Now, the problem is this. There are an awful lot of profiles available to us for selecting exactly what type of VoLTE should we do. Questions about codecs, for example, the type of the vocoder that we use for coding our speech into digital signals is a question that needs to be addressed. For this reason, there are multiple documents such as IR92 and IR65, in particular IR92, that give you a baseline VoLTE requirement about what needs to be actually supported by as a baseline for all devices so that they can operate in any environment while they're roaming or between different devices. By the way, I also have another question on the chat. Thank you for asking these questions. These PowerPoint presentations will be will be available to you at the end of the presentation. Absolutely, to Alfred and others, that is gonna be the case. Okay, so what else do I need? Obviously, I also need to have my LTE network with hopefully its good coverage in order to be able to provide voice services wherever the customer happens to be. Now, the LTE network itself does get an impact in deployment of VoLTE, at least a software impact, not to mention improved coverage, which of course is beyond just the software impact. So the base stations, the eNode Bs, the serving gateways and P gateways all need to become aware of the fact that VoLTE is being provided in this network. Why is that? The main reason is the provisioning of a new quality of service. We need to provide a new quality of service for VoLTE because it's an application that we're in charge of, and we want to make sure that the user experience is the best possible. We want to make sure, for example, the latencies are not too high, the packet losses are not too high, and the mean opinion score, or the subjective impression of the customer about voice quality, is as high as it can be. For this reason, everything that is involved in the network, including my transport network, need to know that the packets that are going through the network are not your ordinary packets coming from the internet, but these are packets that are actually carrying speech and therefore need to be treated differently. Now, sometimes this is actually manual work where we need to configure our IP transport network with an awareness about the fact that we have VoLTE services, and sometimes this is partially an automated operation. The second thing is, of course, IMS. Without IMS, where I have my main call control, nothing will happen. But also beyond that, I also need what is called a quality of service management or infrastructure known as PCC, or policy and charging control architecture. Yes, it is in fact officially or by the standards a separate network than the IMS, although in practical deployments the PCC is really realized in a single functionality in the network known as policy, charging, and rules function, which is the quality of service boss in the network and plays a very crucial role, as we will see, in establishing VoLTE calls in the network. So the handset, the LTE network, the transport network involved with that, as well as the IMS and the PCC architecture, are important ingredients in order to be able to provide VoLTE. Now, in order to provide VoLTE, we need to cater for the quality of service that voice deserves. There is a number of ways we can do this, and the LTE standards have decided to introduce the concept of a QCI, a quality of service class indicator, for standardizing the way the quality of service should be provided in the network. As you can see, and this is a very common theme in VoLTE operations, we are going to need two new bearers. Now, this word bearers is simply a short way of saying we need rules and procedures for forwarding and receiving packets between two endpoints. If I have a bearer between two endpoints, then the nodes that are involved in sending and receiving those packets know exactly what to do to provide the required quality of service between the endpoints. I need two of these. One of them is going to be an always-on connection or bearer between the device and the P gateway, the PDN gateway, in order to do the signaling with the IMS network, basically through this path. The other one is an on-demand bearer that I'm going to need, a so-called QCI1, and that is the type of bearer that only comes into existence as needed, or when we are done with it and the call is over, it is removed away. It goes away. So it's an on-demand bearer. However, it is important to realize that there are requirements on the thickness or the bandwidth of this QCI bearer. A typical VoLTE operation for a single user requires a bandwidth of around 50 kilobits per second in a current deployment of LTE networks. There is a question about the cell backhaul, about while VoLTE has voice over IP SLA requirements, I know many operators are using satellite to do their backhaul. How does the latency work with this? It is difficult to do that. It is not impossible, but it is very difficult to do that. Studies show that if your round trip delay is beyond 250 milliseconds, you have a rather high percentage of unsatisfied, but still acceptable VoLTE communication going on. So if we can make our end-to-end round-trip delays within 250 milliseconds, we might get by in general. But satellite communication, as you know, might introduce delays larger than that, and therefore the experience might not be optimal in those type of scenarios. There is also another question about the mean opinion score and the range and value of that. I will get to that in a moment regarding MOS ranges and how that works. All right, so about the QCI, let me remind you that, that the QCI is a standardized way to provide quality of service within the LTE network. In other words, we talk about this QCI, or the quality of service in LTE, from the device to the P gateway, but not beyond. So if I want to make sure that my VoLTE is good beyond the LTE network, as it might be in the case of operator-to-operator communication or operator-to-PSTN communication, then that's a very difficult thing to do. And it is not without problems. Indeed, when I use an over-the-top application like WhatsApp to talk to my friends, the quality is very good, and VoLTE can match that quality in a VoLTE-to-VoLTE call. But it is not uncommon to run into quality issues when VoLTE is interworking with the PSTN or in a roaming scenario. It is a very challenging thing to troubleshoot and correct the problems in interworking in terms of quality of service, because quality of service is guaranteed within the LTE network, but not beyond that. Beyond that, we need other mechanisms to rely on, such as diff-served code points and the ability of the routers to actually cater for higher quality packets, such as VoLTE packets. In LTE, so this is an LTE chart. In LTE, as you can see, once you know the QCI, you know 4 things. If I know the QCI, then I know 4 things. I know the bearer type, I know the packet delay, I know the packet loss, and I know the priority of the packets that go through that bearer. For example, if you notice that for VoLTE media itself, we are using QCI 1, which is given here as an example, is what should be used for conversational voice. We really want to allow no more than 100 milliseconds handset to gateway delay at maximum. And we also do not want to see packet losses greater than, let's say, around 1%, 2 to the power of -2, around 1%. The fact of the matter is that VoLTE can sustain errors beyond 1%, maybe up to 1.5%. But by the time you reach 2% packet error rate on your voice over IP packets, the quality is going to be dramatically reduced. The MOS score is going to drop dramatically, and we are going to have unsatisfied customers. So we know the delay. We know the packet loss must be less than 2%, preferably around no more than 1%. And then we have a priority here. This priority allows the LTE network to choose between its actions when packets are arriving to it all the time for different services. If I'm getting a packet for VoLTE and at the same time a packet for internet, obviously it is the packet for the VoLTE is going to trump and have a better priority or a higher priority than the lower priority internet bearer, which would be using QCI 8 or 9. So this is where the internet would be. This is where the VoLTE would be. And finally, that always on bearer with QCI 5 is the one that would also have a very high, actually the highest priority The lower the number of priority, the higher priority it has. It has the highest priority for scheduled packets and handling within the network. Please note that the QCI5, which I use for VoLTE signaling, is also very, very, it requires a very low amount of errors. Only 1 out of 1,000,000 packets are allowed to go bad, and we still call it okay for VoLTE operations. About MOS, or mean opinion score. The mean opinion score is highly related to these two: packet delay, packet loss, and what is sometimes called jitter, or variation or variability in the inter-arrival time of the VoLTE packets. A MOS score is traditionally a number between 1 and 5. I would say you always want to be as high as you can. Closer to 5 is better than closer to 1. In general, MOS scores below a value of, let's say, 2.5 or 2.6 are not acceptable. And we want to be beyond 3.5 and above as much as we can. All right, so let us open the architecture and look what's in there and what we need to worry about. So I'm not going to talk too much about the LTE part. I suspect that most of you are familiar with your LTE networks, the MMEs, the S gateways, and P gateways, but look at the other functionalities that we need in order to provide a good and solid VoLTE experience. The IMS network is a very elaborate network. It has many, many functionalities. Most of the functionalities in the IMF, the most important ones of which are shown here, can be deployed as software that runs on certain type of servers. In other words, it's very much a cloudified type of network. This is not true about all the IMS nodes. Some of them need to work in very real-time fashion and work on specialized hardware, as is the case with media gateways, whose job is to do transcoding, the translation of the IP on one end to something that might be non-IP on the other end, such as other codecs, the G.711 and things like that, that might be used in the PSTN domain. So we need multiple nodes in IMS. First of all, we need a node called call session control function, which is the brains of the call control in IMS. The CSCF is very much like the MSC of the 2G, 3G circuit switch world. Without the CSCF, we cannot operate. It is such an important node and has so much functionality that it comes in 3 different flavors: the proxy, the interrogating, and the serving, as we will see in a moment. Then I need to have an application server where I can reside my voicemail services, my ability to provide supplementary services like a call on hold, potentially conference calling, and things like that are actually hosted by an application server, usually referred to as the telephony application server. Then I need nodes that do the job of interworking. You can see that all these nodes are somehow involved in connectivity to the packet switch network, and this is where the interworking with the PSTN comes into picture. I need to have media gateway control function, the job of which is to find the most appropriate media gateway for the subject of transcoding your voice from one format to the other format. And also I need to have signaling gateways, not to be confused, by the way, with the serving gateway down here, but signaling gateways potentially to translate the signaling that is IP-based in IMS to a signaling that is non-IP-based, for example, IZOP-based in the packet switch telephony network. So the IMS is a sophisticated network. It needs a lot of components, and it is not possible to have just a single box that does the entire magic in one way or the other. On the same note, it is a very important piece of the equation to understand that the signaling path and the user plane or the media path are not necessarily the same and are handled differently in VoLTE. We have already seen that. For VoLTE signaling, we had QCI5, which was a IMS signaling bearer, and then for media, we had QCI1. So your voice over IP packets do not follow the same pathways that the signaling messages in generally do. In this diagram, you see there at the top that we have something called SIP and diameter. These are the name of the protocols that we use for allowing the machinery of IMS and VoLTE call setups to work. What I want you to take away from this is a couple of things. One is that, as you can see, the dashed red line and the gray line, they are separated from the thicker blue and the green line, which are the connection to the internet and probably the carriers of also the VoLTE for carrying the voice over IP packets. So the same blue and the green line that you see are going to be the carriers of the voice over IP. Obviously, for internet, this will be a different one, but for voice over IP, we will be using a QCI bearer that is dedicated for carrying user data media. That's the first thing I want you to notice. So different paths for user plane and the control plane or signaling in VoLTE operations. The second thing I want you to note is this. If you're a network engineer who wants to understand VoLTE, troubleshoot it, and make sure that everything is working correctly, you have to become familiar with a new set of protocols and procedures that you've never seen before, not in the circuit switch world and not in the LTE. A good example of that is the SIP or the SIP protocol, the session initiation protocol, with its own machinery and its own commands and its own fault codes that need to be understood and managed by the network engineers. This is actually an important part of any network deployment of VoLTE, is understanding the expanded skill sets that we need for operation of a VoLTE network. There is another point that I want to mention in here, and that is the existence of an HSS, the home subscriber server, that in general provides subscriber data for the LTE network. This is a question that you need to ask yourself when you deploy VoLTE. Can I do with that HSS, or do I need a dedicated HSS type database for my IMS network? In fact, the previous slide, if I may go back to that, actually was hinting at that. You do observe that in this case, there are two different HSSs located here. One dedicated to operations in IMS, and the other one dedicated to operations in LTE. After all, just because I have a VoLTE device does not entitle me to make use of IMS services in general. I could be using just an LTE dongle or MiFi that typically does not support VoLTE. In that case, the dongle or the MiFi would be hosted or catered for at the HSS in the LTE and would not appear at the HSS for IMS. It is actually one of the many choices, architectural choices, that we have to make in terms of VoLTE deployment. All right, so let us now change pace and talk about the VoLTE call operations and some important considerations for VoLTE operations in general. Let me see if there are any questions here on the chat window. Please keep them coming. Thank you very much. There are many steps that must happen before a VoLTE call is established. It is actually quite mind-boggling to look at a ladder diagram or a signaling diagram of a VoLTE call setup. It is quite intimidating. I can tell that from my own personal experience. And troubleshooting VoLTE is not an easy task because we really have to expand our views and look at an end-to-end procedure for the best possible troubleshooting that we might want to do. But let us look at operations in general. First, we need the LTE coverage. And remember what I said, if we don't have it, if the LTE coverage is poor, then we might consider that other technology, single radio voice call continuity, where the mobile does not need to have two radios, but just one, and the mobile can do mid-call handoffs between 4G and the 2G infrastructure. This is an important decision that we must make, whether we need this technology or not. Typically, in the larger North American carriers, SRVCC has been an interim or temporary solution that later on has been abandoned when the coverage of LTE has become on par or better than the coverage of 2G and 3G network. The second thing that we need to consider, or the next step that needs to take place, is of course connectivity to the LTE network. You can never make a call, even though the IMS might be handling your call. You can never make or receive a VoLTE call without connectivity to the LTE network. This is very interesting because this means every single VoLTE user has to actually connect in some form or fashion to two different networks, the LTE network and of course the IMS network later on, as you can see up here. So it's a two-stage access procedure before I can make that VoLTE call. The next thing to consider is the fact that we need, just like internet is its own packet data network with its own access point name, which is an identifier that gets the device to the correct cloud, to the correct data network cloud. The same applies to IMS. We need to come up with a new access point name for our IMS, which basically directs the LTE network to take the connectivity all the way to the IMS cloud. Do we need dedicated P gateways for that? That is quite possible, and it is not uncommon to actually potentially dedicate P gateways for just the IMS infrastructure and separate that from P gateways that take my connectivity to internet and other packet data networks. And then there is that QCI number 5 plus the QCI 8 or 9 that I might need for my internet connectivity. In other words, before LTE, all my customers, I said that wrong, before VoLTE, all my customers needed was that single always-on connection to the internet. With the advent of VoLTE, now they're going to need two such always-on bearers, one to the internet and one to the IMS. That is an impact on the network, in particular on the P gateway, which should be able to handle millions. Typically, these are machines that can handle hundreds of thousands, upwards of millions of connections at a given moment in time. The next step is IMS registration and authorization. IMS is very chatty, and there are many messages going back and forth before registration happens. But then we should also consider the roaming scenarios that are involved in registration. No matter where you are in the world, in general, it is the home IMS that needs to know that your device is powered on and ready to make and receive VoLTE calls. This is also a challenge in terms of IMS interconnection and connectivity. We'll take a look at a little bit later. It involves a lot of signaling to make your roaming scenario work properly. Then we get into active mode, and there are many variations on this regarding the type of call that we want to make, the type of codec that we want to use. Like I said, there should be a baseline that we follow in order to make sure that our devices are operational outside our network anywhere in the world. We then need to do that end-to-end SIP signaling, or session initiation protocol signaling, in order to make or receive a call. And as we do that, the devices will be negotiating quality of service and the type of bearers that we want to establish. Video, without video, just simple voice call, etc., are things that actually need to be negotiated within the network. Finally, once the network knows that the call is going to be taken, we have to establish a dedicated bearer with that 50 kilobit per second bandwidth that I mentioned, QCI1, that needs to come into place in order to establish that call. And that is not the end of the story. It's a mobile network. We move around, and it is perfectly it should be one of our main goals to actually maintain this call to the best of our abilities so that the dropped calls are not experienced. I can tell you from own experience that one of the most important things that any carrier should do once you deploy VoLTE is to take a very close look at your handover operations in general, because VoLTE is essentially the most important real-time service that many carriers out there provide today. And if it's a real-time service, we won't have much time for delays in handover. Handovers must occur without any glitch, with the best possible result, without dropping the call. This is not the case with a customer that is only doing data browsing. If I'm data browsing on my LT device and I'm watching a YouTube video, the fact that there is a lot of buffering happening in the background as I keep watching the video is going to give the network a fantastic advantage in not having to worry about any drops. I could be dropping like crazy and I would not notice anything because I am simply doing a data session with a lot of buffering occurring in the background. We can't say that about VoLTE. VoLTE is hypersensitive to delays that might be caused in handover situations. Let us now also look at the high level. How does a VoLTE call really happen? How does it happen? One might think that a VoLTE call might start by first sending a request to the LT network for VoLTE, and then the LT network goes to IMS and says, hey, there is somebody here who wants to make a VoLTE call. Can you handle that? And then the IMS goes back and says, yeah, let's start handling that VoLTE call. This is absolutely not the way that this happens. So what really happens in a VoLTE call is actually this. Remember that always on bearer that we had with QCI5? Actually, the device is going to use that to tell to the IMS network first that I want to make a VoLTE call. This is super interesting because this means the LT network actually might be totally oblivious to the fact that the device wants to make a VoLTE call at this point in time. The IMS gets to know first. And the reason for this mechanism is the following. If I actually had the mobiles negotiated the quality of service with LT network, it would open a loophole for hackers to constantly ask for a different quality of service from our network than they are really entitled to have. So it's a clever way to have the device first ask the IMS network, I want to make a VoLTE call with this type of bearers, with this type of codecs and these characteristics, whether there is video or not, for example. And then the IMS network then goes down and uses that PCC architecture, as you might recall, the policy and charging rule functionality to ask the LT network in step number 4 about the creation of a QCI number 1. which allows the VoLTE packets to pass through. So please note, we are going through the other way. Device to IMS. IMS then asks the PCC architecture that in turn asks the LTE network to establish the dedicated bird that we need for the VoLTE. This closes an important loophole that would expose our network to require requests for any quality of service at any time. One last point here. IMS is agnostic to the radio access network. IMS doesn't know if the radio network is, or doesn't really care that the radio network is LTE or NR or something else, or Wi-Fi for that matter, or even wireline for that matter. In other words, IMS does not know the concept of QCI and quality of service. This is exactly why we need a PCC architecture that translates the requirements for VoLTE to something that the LTE network understands. This so-called PPPP, because all the nodes involved start with the letter P in front of them, PCSCF, PCRF, PCEF, for enforcing the quality of service, and P gateway, these 4 Ps are essentially the mechanics of a VoLTE call setup in the network. A lot of important troubleshooting can be done by understanding this procedure and following the Ps in order to find what might have gone wrong in the moments of the call setup, as an example. I will not walk you through the IMS registration in details. I'll just show you how extremely chatty and complicated it can be in general. And as you can see, it involves many nodes, it involves many operations and signaling before I only get registered at my serving call session function. This is my registrar in the IMS network, where the device simply becomes registered. So even if I'm roaming around in a different network, such as, let's say, for example, I'm a Japanese subscriber in US. Obviously, I will be using the LTE network in the American operators network, and actually anything down here essentially will be part of my visited network that I am roaming in. Now, when I register, like I said, it is the home IMS in Japan. All these nodes in the Japanese network would need to know where I am, and thus make an association between the Japanese IMS and the hosting IMS, namely the American IMS that the Japanese subscriber happens to be in. So there will be an association made between these two nodes in particular that will allow subsequent signaling for roaming to happen. So roaming is not easy. Managing roaming is not easy, and there are multiple variations to how it can be done or achieved. But before we take a look at that, let me also walk you through the basic call setup in VoLTE. The basic call setup in VoLTE is going to be involve SIP signaling between the endpoints. You dial a number, that number is going to be translated using certain databases so that routing of these signaling messages can be made to the other end. And as part of this, we also do what is called media negotiation. It is important to understand that it is the endpoints that are negotiating the codec types, AMR, EVS, and others possibly that might be supported between the endpoints. At any point in time, the networks can decide to override this and allow only a certain type of codecs to be used. But the fact is that the caller offers certain type of media characteristics, and the receiver accepts one of those possibles, one of those offers that has been given to it in this message. With the phone then starts ringing, an answer comes back, and then the VoLTE call flows. The voice over IP packets flow. Here is a problem for us that we need to be very conscious of and understand. At what point do we need to make that dedicated bearer, which is something costly, right? Dedicated bearers are costly because they occupy resources. At what point should we make that? Should we make it right after the SIP signaling has been done? Or should we make it somewhere later, maybe here, where we are sure that Bob actually wants to accept Alice's call? You see what I'm pointing at? If I actually make the dedicated bearer too early, then there is always a chance that Bob says, oh, I really don't want to talk to Alice today. I'm going to hang up. Bob hangs up. And the result is that we have actually created a dedicated bearer that potentially will not be used. On the other hand, if I wait too long for making this dedicated bearer and only make it after Bob is really answered the phone, I am running the possible risk of delaying the call setup and thus causing a glitch or a gap in the connection before Alice and Bob can say hello and hear each other. These are the type of engineering decisions that you need to make when you deploy VoLTE. Preconditions or no preconditions is the name of this particular type of problem that you might be facing or trying to address. So this one actually shows you a very complicated roaming scenario that I'm gonna kind of skip at this point and not to talk too much about. But this is the most sophisticated roaming that you can imagine. We have a Japanese subscriber and a Finnish subscriber that happen to be also in different networks. The Japanese subscriber is in Spain. The Finnish subscriber is in the United States. How do they find each other? It's actually not difficult to appreciate that now once you know that the registration builds these associations between IMS networks that allows the routing of the call all the way from the Japanese subscriber in Spain to the Japanese network, where the Japanese subscriber is, of course, resides, to the Finnish network, which will then be able to route that call to the American network where the Finnish subscriber happens to be. This actually does happen, and it's routinely happening in many VoLTE scenarios, but it involves a very elaborate roaming agreements in place. I would also like to say that we also have PSTN interconnectivity as a problem. Interconnection between interworking with PSTN is not a straightforward matter. In particular, the media gateways are very sophisticated machines that work in real time. These are not your normal functionalities that you run on a piece of software on commodity hardware such as servers. These machines are working in real time, transcoding from codecs that we use in VoLTE to other codecs that are deployed in PSTN domain and PSTN operations in general. So a lot of problems in my personal experience with PSTN interworking involves media gateway and media gateway issues where packet losses within the network could occur in general. Finally, I want to tackle a little bit of and put these ideas together. We've actually talked a lot about the issues that you might run into when you deploy VoLTE. I do want to say that in general, an important thing to keep in mind is the fact about packet loss over the air. In general, call quality issues due to RF coverage are quite difficult. After all, you all know that probably our weakest link in all these scenarios is the air interface. The error interface is our weakest link. And so to make sure that VoLTE enjoys that less than 2% error or packet loss, we actually have to allow retransmissions over the air in general to make sure that operations work without any issues. Other than that, VoLTE packets are never ever retransmitted anywhere else in the network. Only over the air, we must allow retransmission of the VoLTE packets. Now, you can imagine this is not going to cause a repetition of what you say on the listener's phone or the handset, right? You're not going to hear hello, hello, because what we will be retransmitting is only a 20 milliseconds worth of speech. A very small amount of your packet sample is what is being packetized and sent over the air, and that's what we will be retransmitting. We need to configure and optimize these operations over there in general. Another issue that we need to also think about very hardly are the databases we need to have in place. Many times the routing of the calls may not work due to deficiencies in our databases, such as the enum database or the DNS operations in the network that would cause problems in our VoLTE operations. So in terms of resources and impact on resources, VoLTE absolutely impacts my data users, no question of doubt. The reason is not because of those 50 kilobits per second, which are quite small. The great reason is that nothing can happen in LTE without signaling resources. And signaling resources are a limited amount of resources at any given moment in time. If I have a lot of VoLTE users, they can deplete my radio network, my LTE network, from my signaling resources. So another very important thing to keep in mind is the optimization of signaling resources when we have a mix of VoLTE and data users in our network. There are many interesting features out there that if you want any questions about, I'll be more than happy. But there are features like TTI bundling, robust header compression, and segmentation and concatenation of voice over IP packets. That these are all features that we need to ask: do we need them or do we not need them? In particular, robust header compression is one that most people agree we're going to need, because we will be using IPv6 as a way to route our packets in general in VoLTE. And because IPv6 packets are so large, we need to compress these headers effectively to save bandwidth and operation. And this can easily be done, or effectively be done, using a feature called robust header compression. All of these are part of the profiles, the IMS profiles that I was talking about. These features and some others are decisions that we need to make about whether we need to deploy these or not for good operations. Finally, visibility to network operations is of paramount importance. We need to make sure that our MOS scoring, it gives a true reflection of the user experience. Not an easy thing to do, because the best place to measure the MOS is in the handset, and we typically don't have access to that information, but we have access to the traversal of the packets through the network. So it is not an easy thing to get a good MOS score as a means to understand our user experience, but we must do our best by deploying the probes in the right locations to get as much information as we can. It is much easier to measure things like accessibility and retainability from the network side, as we have a plethora of very powerful counters in general to understand how well and easily our devices can access and maintain their connection in the network. I hope you enjoyed this short presentation. I just want to summarize the big picture here, that IMS, VoLTE needs IMS. IMS is the big enabler for VoLTE. IMS itself is a very powerful and flexible network that allows for call control and supplementary services and rich communication services within the VoLTE domain. We need to understand that the device now requires always on bearers, not just to internet, but also to the IMS cloud. Many enhancements and features are there to provide the quality of service that we need to provide to the customers, QCI 1 and QCI 5 among them. And let us not forget that VoLTE is essential, but also has great impact on the network in terms of my data communication and the data users because of its demand on resources in general. As such, resources must be dimensioned accordingly. That's it, class, and thank you so much for attending this short webinar. We hope to see you at the Mobile Carrier Show in March 30th to April 1st, 2020 in Dallas, Texas. I will be also there to give a similar presentation regarding VoLTE operations in that location. Thank you very much and hope to see you again.